Let's assume you're given this kind of problem which says a spherical balloon is being inflated such that its volume, which is being denoted by V, is increasing at a rate of 100 cubic centimeter per second. And how fast is the radius R of the balloon increasing when its radius is just 5 centimeter? In this scenario, we are given a balloon which is being filled with air and its volume is growing by 100 cubic centimeter per second. And we simply want to know how much or how fast the balloon radius is increasing when the radius is just 5 centimeter. So, notice that the formula for the volume of the sphere is given by V, which is equal to 4 divided by 3 pi r cube. V, which is equal to 4 divided by 3 pi r cube. And in this case, the V simply stands for the volume, and our R here simply stands for the radius. So to find out how fast the radius changes, we simply need to take the derivative of the volume. So formula for this gives us the relationship between how fast the volume and the radius are changing over time. So the formula for the derivative or derivative formula, right, is given by dV. Remember, this is volume all over change in time, which is dt. It's equals to 4 pi r square dr all over dt. 4 pi r square dr all over dt. So the dv all over dt, which is this simply tells us the rate of change of volume. And dr all over dt, notice that this is r. dr all over dt depending on the radius and the rate of change of the radius. So at this point, what we need to do is to plug in our known value. There are two known values here. The first one is the rate at which the volume is increasing. The rate at which the volume is increasing is given by dV all over dt, which is given to be 100 centimeter cube per seconds. So what about the R? The R, which is the radius, let's use small letter. The radius is given by 5 centimeter. So we can simply use the formula now and plug in all our values. So we said the formula which we'll be using is going to be dV all over dt, which is equals to 4 pi r square dr all over dt. So notice that we said dV all over dt is simply going to be 100 centimeter cube, right? So here we are going to put 100, which is equals to 4 pi. What is the value of r? And our radius is just 5 centimeter. So we are going to replace the dr all over dt, because we have already replaced dV all over dt. So we can now simplify it. We have already substituted the value. Now we can simplify it. Remember, on the r we have square root. So this is simply going to be 100, which is equals to 4 pi. 5 to the power of 2 is simply going to be 25. Here is going to be dr all over dt. So if we multiply 4 pi multiplied by 25 is simply going to be 100. Therefore, here we are going to have 100, which is equals to 100 pi dr all over dt. At this point, the unknown value is simply going to be the dr all over dt. So we are going to solve for dr over dt. So how can we do that? So we are simply going to divide both sides by this. So if you plug in here, so this is going to be dr all over dt, which is equals to 100 divided by 100 pi. This will cancel out. 100 divided by 100, we're simply going to be left with 1 divided by pi. Therefore, our final answer is simply going to be dr all over dt, which is simply going to be 1 divided by pi, putting our unit, which is centimeter per seconds. So this is our final answer. So this is it for this problem. I hope you find it helpful. Please, if you do, don't forget to click on the subscribe button. Thank you. Let's assume